Hello students, I'm going to do the notes for math model, and today we're going to be looking at Boyle's law, which is a type of inverse variation. Boyle's law is just a relationship between the pressure and the volume of gas. This is the general formula. Sometimes they have a second formula. I haven't decided to use it for now. This is the original formula, you can say. And if you can see, it's inverse variation. This is volume. B represents volume. P represents pressure. And K just a constant. Now let's look at what pressure, in case you guys forgot what pressure, volume, and then we also have force, because we're using force. I have some definitions here for you. So first, the units of pressure, you're gonna see unit, you're gonna use standard atmosphere, which is ATMs. You might see torque for this assignment and millimeters of mercury, and this is the letters they use, mmHg. This is another type of pressure, but I don't think we're gonna use it. And this is another one that you guys are familiar with, like the tires, the PSI, pounds per square inch. But for today, we're gonna use for sure, we're gonna use ATMs, torques, and milligrams, and this is how they relate. 1 ATM equals 760 torrs. They equal 760 mmHg. This is how much they equal for the other two, but we're not gonna use it. Okay, quickly, what's the definition of volume? Well, you guys know. The amount of space that a substance or object occupies, or that is enclosed within a container. I think today it makes more sense with Boyle's law, something that's enclosed within a container, because they're gonna apply pressure. Also, another definition would be the amount of space occupied by a three-dimensional object as measured in cubic units, such as quarts or liters. Today we're going to be using the liters for Boyle's law. What's the definition of pressure? The application of a force to something by something else in direct contact with it. The pressure exerted in every direction by the weight of the atmosphere. And that deals with the ATMs. ATMs atmosphere, the standard atmosphere. All right. The last definition would be force. In case you guys forgot, it's from science. A force is a push or a pull upon an object resulting from the object's interaction with another object. So Boyle's law, we're gonna be putting pressure on gas. So again, this is Boyle's law. It's an inverse variation. These are what each letter means. A visual example would be this. For example, this is a container and it contains gas. These numbers on the side are liters. So liters. And you're applying pressure with this thing, or something is applying pressure, because it's hard to compress this. So volume and pressure. And then the same gas, once you apply the pressure, right? This one, you basically not applying any pressure. Here you are applying more pressure on the same gas, and look what happens with the volume. So with the first one, the volume was 5 liters. If you notice, the first one, the volume was 5 liters. So for this one, the volume was 5 liters. When you apply the pressure, the volume goes down to 2 liters. I haven't specified the pressure. This is just a general example. So what does it mean? Here we had the pressure was low. On this one, the pressure was high. So what happened? If you don't have any pressure, the volume stays, you can say, the same, 5 liters. This is the volume. If you apply pressure, what happens to the volume? It decreases, right? There's less volume of the same gas, less volume. You can see the difference here. So graphically, this is the x axis, which is represents pressure. They can use ATM, they can use torr, like we said. They can use mmHg. For this one, they're using liters. They can use milliliters and stuff. So imagine this is the volume. This axis represents the volume. This axis represents the pressure. So basically, what the graph tells you, the less pressure we have, the more volume we have. So volume is high, pressure is low. So you can write it. Let me write it here. If if the volume is high, more than likely the pressure would be low. If the volume is low or less, I think low. I'm just trying to make sense with you guys in simple words. So the pressure would be high. So again, low pressure, larger volume. So let's put larger volume and less volume. The higher the pressure, the less volume you have. So again, less pressure, more volume. High pressure, less volume. That's why it's an inverse variation. As one increases, the other one decreases. As this decreases, this one increases. As this increases, that one decreases. So they're inverted. Now let's look at an example. I'm gonna use this formula. So we're gonna use V equals K over P. And let's put V represents volume. Again, P is the pressure on the gas. And then K is just the constant. Constant varies depending on the amount, on what they're using. Like this is just, that's why it's a constant. It's gonna be different for each experiment. But how does it relate mathematically? Well, we sometimes we are going to be asked for the volume or the pressure or the constant. So here, for example, they're given us at 1.7 ATMs. So you know ATMs, like I told you, that's the pressure. That's a P. A sample of gas takes up liters. So that's the volume. Liter represents volume. So let's put here for volume 1, they gave us 4.5 liters. And for pressure 1, they gave us 1.7 ATM. So K, we don't know K for, I'm going to put here step 1. For step 1, we don't know K. So we're going to use this formula to find K. So what's the volume of 1? I'm going to put volume 1, 4.25 liters equals the K over the P, pressure 1, which is 1.7 ATMs. So they want to know what's the constant when this pressure is put on a gas that takes up 4.25 liters. So if I draw this, let's say I'm gonna draw like this. There's different ways of drawing this. So this is 1, 2, 3, 4, and 5. So 4.25, let's say it's right here. So there's gas here, molecules, and they're applying pressure here with something. I'm just gonna draw it like that. So they're applying, this is the pressure, and they're using 1.7 atmospheric pressure, standard atmospheric pressure. So they're applying pressure to the gas and they were able to reduce its volume to 4.25. So the volume here is 4.225 liters. Now they're saying to find K for the first step. So what are we going to do here? We're going to multiply that division. So the inverse of division is multiplication. So we're going to multiply by 1.7 ATMs. 1.7 ATMs. So all of this becomes 1. So K is equal to, and I have done it beforehand, 7.225 ATM times liters. So that's a K. Now, for step 2, if you keep reading the question, it says, if the pressure on the gas is increased to 2.4 ATMs, what will the new volume be? So for step 2, volume 2, we don't know volume 2, because that's why they're asking. Why would the new volume be? Volume 2. For pressure 2, we have 2.40 ATM, right, which is this one. So the new pressure, this is pressure 2. Let's put 1 here and volume 1. Pressure 2 is 2.40 ATM. The constant we found here. Constant is the same for both. There's no 1 or 2. And ATM per liter. All right. So now applying the same formula, we can find the new value. So volume 2, it's equal to the pressure, 7.225 ATM times the liters, over the pressure 2, pressure, right? Pressure in the formula, so pressure 2 would be 2.40 ATM. If you notice, there's ATMs here and there's ATMs at the bottom, so those become a 1. They don't influence anymore. And then if you divide these two, you get that volume 2 would be 3.01042 liters, or you could just say 3.01 liters because we still have liters there, and that's what we want. We want volume. Volume is measured in liters. So visually, what happened, guys? For those of you that like visuals, I like them. So there's 1, 2, 3, 4, and 5, right? 1 liter, 2 liters. So this is liters. 3 liters, 4 liters, and 5 liters. So what happens when they put that amount of pressure? The volume went right here. It's really close to that. So imagine this, and this is the molecules now of the gas. So before it was like what, 4.25, with the pressure of 2.40 ATMs, it went down to 3 liters, so 3.01 liters, really close to 3 liters. So you see it lost volume because the pressure is higher here and here. So this is a higher pressure. This was the lower pressure, and you notice there's more mass, more volume, I mean, in the lower pressure, and there's less volume on the high pressure. All right. Now for today's assignment, I'm gonna do this 6, 8, and 10. The first ones I gave you the answer. It's asking you what is the equation of Boyle's law? That's the equation. What does the letter P stand for? Pressure. What are the units for P? Like I told you, it can be ATM, standard atmosphere. It can be mmHg, millimeters of mercury, and it can be torr for this assignment. What does the letter V stand for? It's the volume. What are the units? Usually here they use liter, milliliters, and that's it. They don't use something else. There's other types of values, but not for this assignment. And there's a bunch of types of units for pressure and volume. There's many, many more. Let me zoom in. So for this one, it's asking you, let me zoom one more right there. It's asking you a balloon is filled with 12 liters of air, a pressure of 2 atms. What is the volume of the balloon if the pressure is changed to 3 atms? So let's start with this one. So this would be volume 1, that would be pressure 1. The general formula is this. And there's another way how to solve this one, but I'm not gonna touch it. Like on this assignment, there's some questions like that, but you can solve them like this. So volume 1, they give you volume 1, 12 liters, pressure 1 is 2 atms, and K, we don't have it. So remember, this is step 1. So we need to find K. So you do substitute 12 liters, K, and then 2 atms, right? So this is liters. So now to solve for K, you multiply by 2 atms, both sides. This cancels, you're left with the K. So you get 2 times 12 is 24 atm liters times the liters, right? So that's the K. For step 2, if you keep reading, what is the volume of the balloon if the pressure is changed to 3 atms? So if it's changed to 3 atms, so okay, so we had volume 2, which is this, we don't have it. Pressure 2 is 3 atms, so this is pressure 2, 3 atms. And the K is the one we found, which is 24 atm times the liters. So to find the volume, volume 2, we're going to divide 24 atm times liters over the 3 atms. The atms, again, they go away, so we're left with liters, which is volume, which is good. That's what we want. So 24 divided by 3 is 8 liters. That's the answer for step 2. Visually, and this is what I want you guys to do. What do I want you guys to do? I want you guys to draw the diagram. So in this part, so sorry, I'm gonna invade this question. In this part, you're gonna have, let's put this thing, and let's go by 2, 4, 6, 8, 10, and 12. Right? So this is from this. So you had something putting pressure on this thing. So you're gonna draw the diagram like this. And these are the molecules. They occupy 12 liters, right? What happens when you increase the pressure to 3 atms? They go down to 8 liters. So for this one, draw the something like this, label the units. So this is volume, this is the pressure, so volume. So 2, 4, 6, 8, 10, then there's 12. So what happens? It goes down to 8. The same, right, mechanism here for pressure. And now the molecules are less. So more pressure, less volume. Less pressure, more volume. So this is 8 liters. This is 8 liters of volume. Volume here was 12 liters. And that's what I want you guys to do, make that connection. Let me do one more. They use milliliters. So milliliters 2000 would be 2 liters. This is 2 liters. And they use 2 atms. It's the same process. It's the same process all you have to do is, so we're gonna use the same formula. Let me do this quick. And then we have the volume 1 is 2 liters, so this is the volume 1. And we have pressure 1 is 2 atms, and we don't have K, so this is step 1. We find K, so 2 liters equals K over 2 atms, and then you multiply by 2 atms, so that cancels, so you end up with K equals 2 times 2, 4 atms times the liters. So we have K now. So step 2, what is the volume? So they want volume 2. They're giving us pressure 2, and we already have the K. So volume 2, we don't know that. Pressure 2 is 5 atms, and the K is what we found over here, 4 atms times the liters. And I'm using liters because I changed that to 2000 to 2 liters. So now apply the formula again. So volume 2 equals the 4 atms liters, right? K goes on top over here, and then the 5 atms. So this is not gonna be a beautiful number, but maybe because I change, so it's 4/5 of the liter, and that would be about 0.8. So volume 2 would be 0.08 liters. Right? And how do you convert that? Use a calculator, guys. Sorry. It's 4/5. 4/5. So that's how many liters with that pressure. So if you draw the thing for both, this is the last step. On this one, it had 2 liters. So I'm gonna put 1 liter, 2 liters, and this is the volume. So 1 liter, 2 liters volume. So this one we know it has 2 liters, right? The volume is 2 liters, and we know this one is 0.8 liters. So the pressure was right here. Something was put in pressure here. These are the molecules, and then it went down to 0.8 about here. So this was the pressure, and now the volume it's less compressed. So this was less or low pressure. This was a high or more pressure. So we get high pressure, less volume, less pressure, more volume. And at the end, guys, do the odd ones. Do 7, do 9, and do 11 and 10, guys. Sorry, one more. Ignore this one, so I don't want you guys to do the last ones. Thank you.